Okay, good evening everyone. Thanks again for joining today's class. And today we're talking a bit on IPv6. We'll just touch it and we'll not go too deep into it, but as much as we can, as far as we can go, we'll go. Okay. So IPv6 is another variant of IP addressing. IPv4 is the standard one that everybody have been using in yesteryears. IPv6 only came in a few years ago, and IPv6 has 128 bits, while IPv4 has 32 bits. So there are millions and millions and even billions of addresses that you can create with IPv6, and IPv6 has some cardinal um, subsets of addresses like we have for IPv4, where you have the public address and you have the private address. It's even more for even IPv4. You have APIPA address as the address of the system itself. Well, IPv6 has even more subsets of address. Yeah, we have the global local address. We have the local address as well. Then we have and those addresses, there are different formats and the way they get started. IPv6 is written in hexadecimal format, while IPv4 is written in decimal format. So decimal format is simply base 10. Hexadecimal format will be base 16. So IPv6 has, for the hexadecimal format, it has about 8 sets of 4 hexadecimal numbers per section. So if you look at it, for example, IPv6 address can be, let me just bring up the notes. Okay. Can you see the whiteboard?
Yes.
It's showing me those system resources. Okay, I will delete it after now. Just give it 2 minutes. So let's see. Oh, it's not letting me use my hand. Okay, just give me a minute and I need to go get my stylus. Interesting. Still not working. thought I used this the last time. It was working okay. Okay. Well, maybe I can explain it with. Just give me a minute. Let me pause this. Yeah, I was saying IPv6 is something like this: 2001 FE 01 1001 1111 0000 0000. So that's 1 2 3 4 5 6 0010 and 1100, something like this. So all this is one IPv6 address. So in IPv6 you have both the subnet mask, the star decider, and the IP address all jammed together as one. So the first half of the address is more like your network part, while the other part is your subnet parts. You remember subnetting, right? Subnetting, when we are doing subnetting, the MAC address of a system, right? It has 48 bits. 48 bits. That's the MAC address of system. The subnet mask also has, I think subnet mask is just 16 bits. So 16 bits. If you add the 16 bits of subnet mask to the MAC address bit, which is 48 bits, it then adds up to become like 64 bits. But what we do for IPv6, right? We have the MAC address of the device of that particular interface. So let's assume the MAC address of the interface. So I'm talking about what's it called? EUI address, extended unique identifier address right now. So that's what I'm talking about. What they normally do is there's a fixed number that we use for that other, for the other side of the subnetted portion, not the network portion. Let's leave the side alone. So we are coming to this other side now, which is 1 2 3 4, this other side. This 0000 can be represented with just this two things. This hyphen can represent all these zeros, because all the sections, all these two sections are zeros. We can, all these trailing zeros, we can just represent them with these two dots. And we can only use this once in the whole address line. We can't use it twice.
Excuse me, please, quick question. The hyphen you're talking about, I can't see it because you're...
Yeah, it's here. It's after every 4 numbers. After every 4 numbers, this hyphen.
Semicolon.
Oh, sorry, this hyphen. Semicolon, yes.
Okay, thanks.
Semicolon, not hyphen. So this semicolon here. So before this 0000, these 4 zeros and these 4 zeros can be represented by this semicolon. And these leading zeros before it gets to this 1 can be ignored. These two leading zeros can be ignored. So if I'm going to write this other side of the address now, I can just write it as dots 10 dots 11. So this is the same thing as this whole thing. So that's something that you just put in the back of your mind of how IPv6 address can be written. Okay, so the other EUI I was trying to show you just now is called the unique identifier. It makes use of the MAC address of that particular interface. I'm going to show you on the lab now, and between in the middle of that MAC address, we'll split the MAC address into two. So let's imagine we have a MAC address of, remember, MAC addresses also uses hexadecimal numbers as well. So let's imagine the MAC address we have is 0, or let's just say, yeah, 0 A B C, something like that, and then we have 1 1 0 2, then we have F, no, we have let's use something else. Let's say E 2 1. So that will give us our MAC address. So what we do if we want to convert it to EUI address, this MAC address, we'll break it in this middle. We'll break this MAC address into two, and then inside we'll inject into this middle, we'll inject FFEE, I guess. I think I have it already. I think I have it already there. Okay. Yeah, FFFE is FFFEE or FFFE. Yeah, I think it's FFFE that we need to inject in the middle. And that's like a standard that has been chosen. Okay, yeah, it is. So go back there. So FF, not FFE, FFFE. So if we inject this FFFE, then this whole thing now becomes the subnet mask, which is equal to 64 bits. Then what we'll then do is to change the 7th bit. Okay, when I'm talking about 7th bit now, we are referring to this A, because each of these numbers, they are 4 bits because they're hexadecimal numbers. So that's 0 because it's a hexadecimal number. If you want to bring it out in bits format in zeros and ones, that 0 will be 0 0 0 0. That's because they will all be nibble values. Then A is actually 10. So A is 10. That's 2 4 6 8. So that'll be 8 and 2 turned on. So that'll be 1 0 1 0. So that's 10. That's this. I'm just bringing these two out in decimal formats. This 8 0 and A. That's what we have here. So if I look for the 7th bit, which is this one, I will flip it. So instead of it being on, I'll turn it off. If I turn it off, then that number will now become my number that I'm going to put here, whatever I get here. So this one that I have here now, I have to flip it to 0, and that will give me something like this: 0 0 0 0 1 0 0 0. So that will be, if I want to put this in hexadecimal format now, that will be 0 8. So that will be 0 8 instead of 0 A. So that will be 0 8 B, C, 1, 1. I'm injecting this one in the middle now. That'll be FF. Okay, let me just put this one here. So that's 1, 1. So I'm injecting this one in the middle now. That'll be F, E. It's a bit clumsy. Let me make it clearer. 1, 1. So I'm injecting that in the middle. That'll be F, 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 E, and then this O2, then E, E, 2, 1. So that will be my final address. Because if I'm ejecting this, I'll write it out correctly. So that's F, 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 oh no, Z. I'm not sure why it's coming up with this designs. Okay. F, 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 E. Good. So like if when I have my MAC address, inject this FFFE in middle and change the 7th bit, which we've done. So we just change the 7th bit from this to that, and that gave us 08 BC 11 FF FE 02 EE21. So we'll just do an example now, and then move on with that one. Like I said, we are just touching it. We're not digging deep into it just yet. So as we continue with our lab, I will then show you some other bits. Close this one. I would go to let's just see the interface first so that we'll know what we have on the interface before we turn on IPv6 and actually see what we have on there. Okay. We go to CLI, enter, enable, we go to configuration mode, config T, and to turn on IPv6 you just type IPv6, use your question mark to tell you how to turn it on. Unicast routing, enable unicast routing. So that's what we want to do. We want to turn on IPv6 routing. So just say unicast routing. So it tells us carried return, and as simple as that, we've turned on IPv6 on the box. So after that, we can do go to the particular interface and check what we have on that particular interface first, so we know what we have there. Then we can use a particular IPv6 address. So see the bit I was telling you just now. So this very first portion of the IPv6, like you have 1, 2, 3, 4 sets, and then these other sets this other set represents zeros, all the other zeros, concatenated zeros. Then I'm using /64 EUI -64. So before I do this, I want to show you the interface and what the interface has and how that FFFE was injected and the last bit was turned to, sorry, the 7th bit was flipped over. Okay, so let's go back to our configuration. Here we'll do show IP interface brief. So we see, okay, Ethernet 0/0/1 is down, so let's use that one. So just go to interface G 0/0/1. I will do show interface G 0/0/1. Okay, what we are looking out for here is the MAC address, which is this one. That's the hardware address, is this. Now when we when we convert this to the IPv6 address, you'll see it will change from this to a proper IPv6 address. Then the injection of FFE will be here, and then this 6/7 bits here will be turned to 1. So that if the 7th bit here is turned to 1, because we are actually looking at this very 0 here. So if we put the 0 out, it will be 0/0/0/0. That's the first 0. And the second 0 will be another. So that means these two zeros will be like 8 zeros. So the second one, which is 4, the fourth, which will give us 4 equivalent in terms of decimal, will be what we are going to turn on. So if we turn that on, so this number will now become 0460, and then just all the other numbers with the injection of FFFE. So we are going to do that now using this command. Interface. So just a minute. Okay, so I think we have to put in the first part before we put in the second part. So let's use something simple. We'll just say IPv6 address, like you normally do for IPv4 address. Let's use the global inside 001. 10. 20, $30, and that's 64. Then I think it's EUI. So use EUI interface identifier. Then I'll just type EUI, EU, and use the tab. Okay, so let's do a show IP interface G0/0/1. The truth is, you really don't need to know this. That's the simple truth. I'm just trying to show you how EUI works. No shots, no shots. Okay. This is disabled. Okay, is it because it's not connected? Okay. Okay. IPv6 address, EUI, this. Unassigned. Why is it disabled? Okay, let me connect something to it and see if it goes. Let's connect this to it. For instance, yeah, that's. Oh no. Yeah, that's connection going. For it, it's open already. Let's see if that turns it on. The show interface brief. Protocol is internet protocol processing disabled. Interesting. Connected. Let's check it out. It's up. It's up. Okay, I'll do exit again, and I'll do IPv6 Unix routing. Okay, IPv6 router. Okay. Yeah, that's not what I want to do. Unicast routing is what I want to do anymore. Unicast routing, static routes. Okay, I'm not sure it's not giving me what I want. Okay, let's try again. Internet protocol processing disabled. It's my first time of seeing this. I'm not sure why it's showing it this way. Okay, shots because IPv6 routing, IPv6 unicast routing. It's really what it does all to turn it on. Okay, Let me try this one and see if it works with this. Oh, I really doubt. No shots. Let's try again. And go into the interface. Interface. Interface G0/0/1. And paste. And let's see. That. For some reason, internet protocol processing is just disabled. I'm not sure why that is. Okay, so what I'm going to do now is I'm going to just connect two systems together using IPv6. I think that will take the problem away. Let's try that. So wasting time with this one. Select that. Let's connect to that. And I just need this. Okay. No. 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 See. IPv6 unicast routing interface G000 no shots IPv6 space down. Okay, and pull up this one, do the same thing. Enable connectivity IP domain. No, again. Interface G0/0 IPv6 uni. Okay, exit. And just do paste, then change this one to 20. Enter our shots and IP now connectivity IPv6 unicast routing. Okay, and so IPv6. Oh no, just show interface G0/0/0. Okay, okay, this one is working. Okay, I think because they are not connected together. So that's the MAC address it had. That's the MAC address it had. So expecting it to have the local address now. If we do it's connected, and I see that then. So that's that. Okay. Break mark the interface MAC address. That show interface. This is up. That's the output consider the MAC address. This. So now becomes this. What happened? The MAC address was split in two. Show IPv6 interface this. Okay. So what I needed to do was to do a show IPv6. Okay, interface. So I'm sure that's why it wasn't showing up. G0/0/1. IPv6 interface G0/0/1. I can't see anything. Show IPv6 interface. Interesting. IPv6 interface G0. Okay, this is not 0/0/1. This is 0/0/0. Yeah. So yeah. Okay. Now that explains it. We had this IP, right? Now we on route 3 we configured 2020 and the MAC address, the link local address is now FFE80. The FF and FE that we did here is now there. So the original MAC address it had was this. Interesting. Okay. So what we are looking at is actually from here. After that first set of, because this one tells us what the link, whether it's link local address or link global or global unicast address. But in this case, this FE80 tells us we are referring to a link local address. Link local address simply mean the interface address. Okay, so it starts with 0, 2, 0, 2, 0, 1, 9, 6. So if you look at all these other ones afterwards, it's the same. So we are going to be looking at 4 of those addresses after that one. So that's this 2 and the other one. So they've not added 0 here. There should be 0 here. So they've taken that leading 0 out. So that should be 0 to 0, 1. Okay, 0 to 0, 1. So if we come here, so we had 0, 0. Here we had 0, 0, 1, 0, 0, 0, 1, 9, 6, 7, 0. So the FFFE will be between the 96 and 70. And FFFE is between 96 and 70. Then we have 9601, 9601. So this is the 7th bit here is what we need to flip. And the 7th bit, if we flip it, I think I was saying 4, it's not 4, it should be 2. Because the bits there will be shift that to one side. I'll bring out my whiteboard again. So what we have this time is the 00001, and what we are considering is what we have this time is 0001. So if we bring these two out, it will just be 0000 and 0000. So, sorry, there's no dots there. It just be 8 zeros. 0 0. So we look at the 7 bits. That's 1 2 3 4 5 6 7, and turn this one on. If we turn this one on, the value we'll have will be then 0 2, because this is 2. It's 1 2 4 8. So that's 2 here. So it will be this hexadecimal number will now be 0 2 0 1. That's what we're going to have, and that's what we have here. If we go down here, we'll see that's what we have here. So they just remove that leading 0 and 201, like we rightly said here. That's what will be here. Then before the 96, before the FE stuff. So that's just because we've enabled the EUI for that particular interface. Okay, I said I didn't want to dwell on this for long but I did. Okay, so that's just showing you how EUI works. So two things to be mindful of is in the bit for the MAC address of that particular interface. If you enable EUI for that interface, what will happen is the MAC address will be split into two. In the middle, you inject FFFE in the middle and flip the 7th bit from the left, or from the beginning, which is the left of the MAC address. Alright, so and we can actually do a ping on both sides, and we'll see that the traffic is going through. You can do that as maybe your lab in your lab time. I've sent you these packet notes already, so you can just try that out in your spare time. So we'll go into Portchannel and see how we can speed through Portchannel. Portchannel is very easy. It's a way of I'll just delete that one. Okay, create a new one. So Portchannel is let's imagine we have a switch, and we have different ports on that switch, right? And we want to bundle these ports together. Let's say we have another switch here, and we have 1 2 3 4 5 ports on that switch, and we want to bundle these 2 ports or these 3 ports together, so that these 3 ports will be seen as a single port, and these 3 ports will be seen as a single port. So what we are trying to do is to bind all that speed of this interface together, so that this whole let's say we had 1,000 bytes for these different ports. So if we do the ETA channel, each of this port will now be going through a trunk, or going through, because we could actually call this a single port. So this port can now be like 3K as against 1,000 initially. These ports can then be 3K as against 1,000 initially. So if we, most times when we are trying to connect between two do an uplink from one device to another device, that's when we really need ETA channel, or sometimes for reliability or resilience. So we don't want one port to go down and everything just dies out. So that's why we need Portchannel. So if one port goes down here, we still have 2K, 2000 bandwidth to transfer traffic. If two ports go down, we still have 1K left. But if three of them are up and running, they all will work together as a single port, and they choose which of the ports will actually send that traffic. So this now becomes more like a logical connection than a physical connection. Even though we have three physical connections there, it transfers traffic through all those three different connections as a single connection. So, but those three connections has to choose which of them is the master, that the traffic we have to go through. Even though that port that is connected as the master is 1K, that whole bandwidth is seen as 3000 or 3K if these interfaces are just 1K interfaces. But if these interfaces are like 10K interfaces, say it's 10, 10, 10, then it will now be like bundled up to come up as 30,000 or 30K interface. So that's simple work of Portchannel. It binds interfaces together to make them look as if it's just a single interface. Okay. And the way we do that is by first of all configuring what we call ETA channel on each of these particular interfaces or channel groups. So ETA channel is what we call it, right? So the first thing we do is to configure the channel groups or the ETA channel groups on these interfaces. So once you do that, it automatically creates what we call the port channel. And that port channel is what we use for transmitting traffic. So it now becomes that port channel is more like a logical port that actually helps us to transfer information from one point to another. I hope that's clear. So once we configure a channel group here, channel group here, and channel group here, and put them all of them in the same group. So let's say this is channel group 1, 1, 1. So it sees all of them as part of port channel 1. If we configure another channel group on this other one, channel group, ideally it's advised that you put all of them in the same channel group so you don't get to, so it's not misleading, but it's peculiar to each device. So I could say on this particular device A, I could say it is channel group 222, and device B is connecting to channel group 111. So port channel 2 is connected to port channel 1. That will work as well. But it's just advised that just make everything consistent. So port channel group. So the channel group we want to configure here will be 1111, and same as this one 111. And then automatically to create the port channels for you. So we can do an example, and so we just see how that works. Mostly it works for switches because the switches that we want to bundle their interfaces together will in this case use a multi-layer switch and another multi-layer switch. Multi-layer switch just simply means a switch that does both switching and routing. So a multi-layer switch does both switching and routing for us. So let's imagine we have one connection there, another connection there, another connection. Okay, let's just use two interfaces for now. Say another connection there. Let's just imagine. And then another connection there, for example. Right, this one down. What we want to do is to bundle these interfaces together, these two interfaces together on both switches, so that it will be seen as one logical interface. What we can do is just open it up, and the configuration is so easy. No, enable config T. Right. No interface. Domain lookup. No IP. We got IP. Okay, doesn't like that command. No IP domain lookup. Okay, because it has domain name as well. Okay. Okay. So now those are just the command to make sure that I don't, if I do end, it doesn't hang somewhere. So I'll I'll just for what do I want to do? The FA01. So I'm actually on this multi-layer switch 01 and 02. That's what I want to configure the entire channel for. So I can just go to those interfaces. Interface fast Ethernet 0/1, and I'll do channel group. Okay, it's channel group, not channel space group. Channel group, let's use one like we said before. Channel group 1 mode. You see, I'm using my question marks, just help me know where I am. So there are different modes, so it could be active, auto, desirable, on, or pass. So we are looking for the one that's using LACP, because LACP is open standard, and PAGP is Cisco proprietary standard, and enable on, just enable Ether channel is just putting the Ether channel on. If I say active, that means it's actively looking to um, enable this Ether channel on these interfaces, or looking for active enabled Ether channel connections to connect with. But if I do passive, it's not going to initiate the Ether channel connection traffic. It's going to wait for someone else who is active to initiate that traffic. So most times what you see is on both sides of Ether channel, where we actually want to put Ether channel, you see most times will be active, except you have an Ether channel end that you don't want that end to generate or to create the Ether channel bundle with the remote side. So channel group 1 mode active. LACP, I think LACP means local access control protocol, and PAGP is port aggregation protocol. Link access control protocol, either link access protocol local. not too 100% sure. You can just Google that and find out. Active. That's it. Just that alone will create my port channel for me for that particular interface. So if I go to the second interface, interface 2, I'll have done this in only one go, but I just want to show you how it's done. Interface 2, I'll do the same thing. So that port channel is already created. So if I do show IP interface brief, you see that the port channel is already created, port channel 1, and I did not create this port channel at all. I didn't do anything on port. I didn't say create port channel or anything. I just created channel groups and the port channel was created, and that port channel 1 would have these two interfaces in them. So let's see what's in port channel 1. We'll do show interface, well, show run interface PO port channel 1. Show run. I'll just do ether channel. Okay, let me just end it. End show run in interface. Nice command. Show run. Okay, it's not allowing me to show it. Okay, show interface port channel 1. So it will tell me, should tell me it has two interfaces on it. Yeah, so members of the channel is this and that. So it's telling me these are the members of that channel, of that port channel. So these two interfaces are part of that port channel. So I'll do the same on this other side so that we have similar configuration. Switch ports this, so this one is already telling me something is happening here. So the line protocol interface this changed up, I hit enter. I'll say no, I don't want that. Enable config t no IP domain lookup, no login console. Okay, I'll go to the interface fast Ethernet. I'll go to interface range. Now I want to configure both of them at the same time. Fast Ethernet 0/1 to 2. So that's how to configure the range. I would just say channel channel this NEL channel group 1, and I want it to be on mode active as well. Okay, so now this also has created a new port for us. If I do end and show IP interface brief, you see the port channel 1 here as well, and it's telling me the line, the status is up and is up. When we check this one, the one that we had before, okay, not this one, check this one before, you see the status was down, but now because I've enabled the other side, both the status is up. So now we can just check the Ether channel and show um, interface P. Okay, no, show Ether channel, show Ether channel summary. Just do the summary one. So it tells us we have the port channel 1 and it's using LAC P, and these two interfaces are part of it. If we do the same on the other side, we'll see the same kind of results. So if we come to this one now and do show channel summary, we'll see the same type of result. So it's telling us it's using P there simply means port in channel. So port in channel, SU simply U means in use, and capital S means layer 2. So this is layer 2 port layer 2 port channel that what I've created here. So capital S is telling me it's layer 2, and then U is telling me it's in use, and then P is telling me that it's a port channel that I've just created. So that's as simple as that. What I've done now is to tie these two ports together. Anything I do on this port channel 1 is going to affect both ports. So if I want, for example, to put this port channel as a trunk port, both interfaces will then be using their interfaces as trunk ports. So I can go to interface ports channel 1, sorry, config T, interface port channel or ports PO1, say switch ports mode trunk, for example. If I do switch port mode trunk, interfaces trunk encapsulation is auto, cannot be configured to mode. Okay, an interface whose trunk encapsulation is auto cannot be. Okay, let me see. Yeah, that's all. Trunk encapsulation, switch ports. Okay, trunk encapsulation. Let's do dot 1q. Okay, now we can then do that command switch port mode trunk. So yeah, what it's asking is we should put a marker on the interfaces that we want on this particular port channel that we want to start doing trunk for us. So this trunk is telling us that anything can go through it. It's just as simple as that. So if you go to the particular interfaces now, say for example interface exits, I'll just say end, interface fast ethernet 0/1. Oh, okay, I should have just exit, sorry. I want to show interface fast ethernet 0/1. Connected duplex, looking for the configuration on it. Okay, show run interface that. I hope it shows me that. Yeah, it has a limitation on it, so I'll just do show run and see what it shows me. On that interface one, see, I didn't configure any trunk under interface one, but it's telling me this is the configuration on it because I've done this configuration on the port channel. So switch port trunk encapsulation.1q is what I did on the port channel. Now it's reflecting on both interfaces that are part of that channel group that created the port channel one. So yeah, so that's it for port channels. Then we go on to you can do some more examples for yourself to see how it actually works and how port channel actually works. So one thing I would just want to round off with today is the access control list. We have what we call ACL and list will be a word man. No, let's go back and create one more ACL. Okay, we have two types mainly, which is the standard, and the third one is a derivative of each of these types. So the ACL come in standard format, standard, and extended. So standard has a number range of 1 to 99. Extended has one, I think one. Extended has 100. Is it 100 to 199? Something like that. 100 to 199. We can actually check that out now. Access lists. Let's use this router for example. Enable access lists config t access lists. Access list has a hyphen in between it. Access lists now, yeah, 100 to 119 199. So this is because it's lab, right? This is the only two it's showing. If you go to real environment to show you a bit more than this, there's another type of extended which starts from like 1,000, and there's another type of extended which start from something higher than that as well. So but just for this class purposes or purpose, we have the standard start from 1 to 99, and the extended starts from 100 to 199. For standard access lists, right, you could actually use a name for each, for both of them. You could use, for both of them you could use a named access list. You could use name to represent either the standard or extended access lists. I'll show you how to do that in a bit. You could use a name to represent either of them, and it's easier to use a name so you know what you are referring to per time, so it's just easy. There are scenarios where you use the standard access list where you just have one thing that you want access to. So most times we use the permit statement for standard access list, and you want to implement the standard access list as close to the source as possible. Is it a source? I think it's destination, as close to the destination as possible, because you are only permitting. So for extended access list, you want to implement extended access list as close to the source as much as possible, because you can actually describe where you want the traffic to go from, as in it's more granular than the standard access list. You can describe, okay, I want the access from XYZ to XYZ. I can specify the ports you want the access for. You can specify the range of ports. You can specify the type of protocols. You can specify the actual, you can specify so many things, but for standard you don't have that luxury. You can only specify the mainly the IPs that you need access to and from. So for example, I'm just doing examples here really. So if I say standard access list, let's say I want to use 10 for example now, and I want like we did for the NAT one the other day, question mark, and I want to like I said earlier, we have both we have a deny implicit statement for any access list. So it's only, there are some scenarios where you want to deny a standard access list, but mostly you want to just permit, because there's already an implicit deny for everything. You want to permit something specific to, so that every other thing is denied. But if you deny something, you then have to somehow permit every other thing for any traffic to go through. Okay, so if I do 10, say I want to just permit something like 1.1.1 to access. In fact, that's what it's asking me for, the wildcard mask. So in access list we make use of wildcard mask. I think I explained wildcard mask before. Wildcard mask is the opposite of, not like opposite, it's just, yeah, the other way of writing subnet mask. So if I have a subnet mask of 255.255.0.0, my wildcard mask for this will become 0.0.255.255. So wildcard mask is simply 255 minus the subnet, the value of the decimal value of this, of the subnet mask. Of subnet mask, I'll say per octet. Per octets. Decimal value of subnet mask per octet. So each of these are octets because they only have maximum of 8 bits, right? So 255 minus decimal value that you have there. So 255 minus 255 give me 0. 255 minus 255 give me 0. 255 minus 0 give me 255. 255 minus 0 give me 255. So that's how we come up with wildcard mask. Because this is subnet mask and this is wildcard mask. All right. So we just go back there, and it's asking me for the wildcard mask. Let's just use /24 for example. In fact, let's use /30 for example. Yeah, let's use /30. Just something that comes to my mind. /30 will be 0.0.0.3, something like that. Yeah, that will be /30, and that's it. So it's only allowing us, permitting us to do the IP address. Well, this is one way. So let me see if it will choose, say permit. So it's telling us address to match or any. So I can say permit anything. That means I want to deny something later on, or I could say permit hosts. So if I say permit host, that means it's permitting only one IP. So it tells me what's the host address. So I can just say 2.2.2.2, something like this. So that will be the only thing it's going to allow. But if I just say an IP address, it wants me to write the wildcard mask, the range of IP addresses that I want. So those are the only three options that it gives you to make use of. As against extended access lists. Let's see extended access list, for example. When we use extended access lists, extended access list will be so let's say 110. Now a lot more options. Now we can say we want to permit see a lot more options. So we want to permit just TCP traffic. We don't want to permit the UDP traffic. We just want to permit the TCP traffic of a particular source of 1.1.1.1 and source wildcard mask. So this is source wildcard mask of which we had before. Can just use the same one, 3, and then it's asking us again, okay, what's the destination address? So from source to destination address. So I say, okay, match only packets on a given port number. So I'm saying permit only TCP from this IP to okay to a destination, because I can either put the I can either use EQ, that's equals or greater than or hosts or less than or um, negative or not equals, sorry, NEQ, not equals, and range. I can use any of these options, but I just want to use destination now. So let's say destination is 3.3.3.3 and then destination wildcard mask is 0.0.60.7, for example, and I just want to match it on a given port number. So maybe it's only ICMP I want, so I can say EQ equals, now it's asking what's the port number. Okay, maybe says just telnet I want, for example, or F, because I've already stated here that it's TCP. If I state a different thing here, what is going to be giving me equals here will be different. So in this case, let's just use maybe FTP, for example, equals FTP, and then I can just hit enter. So that's a lot more options. Now, if I want to use the named access list, I have to use the IP access list first. IP access list tells me, oh, this guy is interested in using the named access list. So I can just say, okay, I want to use the extended type of access list. And then it tells me what name do you want to use. So it already cited the extended access list range and it's asking me, okay, what name do I want to use? I don't want to specify the range. I just say, okay, I want this to be called tip lab, for example, or tip. I want this access list to be called tip to internet. That's what I want it to be called. So if I do that, it now add this extended knuckle to it. So now I'm in the named access list domain to start typing. Like I was in the global configuration mode, now I'm in the named access list configuration mode. So I can then type what I want here. I can say permit or deny anything, and I can specify the numbers. So if I say permit, it now gives me a number that I want to permit on. Okay, so I specify the sequence. I can say, okay, 10 or 20 or 40, depends on what I want. Most times I like starting from 10. So I can say 10 permit. Then it tells me, okay, what do you want to permit? I say permit ICMP from a host, which is 1.1.1.1. Now it tells me what the destination address do you want to get to, 3.3.3. Okay, I can specify the host again. I'll say host. I want to get to the host 3.3.3.3. So once I do that, it says, okay, which of these do you want to allow? I just want to allow any of them for the ICMPC. The options he gives to me here now are different from the one he gave to me when I was trying TCP, or when I tried TCP. So these are so many options that can give when you are configuring extended access list as against standard access list. So after I've configured this, once I see carriage return here, I know that my command is complete. I can do end and then just see what I've configured. See, you can configure configure access list as much as you want on the device, but it will do nothing until you apply it on an interface or until you apply it somewhere. If you do not apply that access list, it will never work. So how do we apply the access lists? You can go to the particular interface you want to apply the access list on. For example, if I wanted this interface to be the one I want this permit statement to work on, I say, okay, permit ICMP from host this, maybe the host is this way, to host that is maybe somewhere here. What I want to do is just go to that interface and permit it outbound. So I'll say go to that interface. Let's go to the interface, sorry, config T. You have to get to global configuration mode, then interface G 0/0/0, then we'll go IP. You need to specify the IP access group. That's what you need to do here, not access list again. So IP access group, then you need to specify what is the access list name that you want to use, because imagine we have already configured as IP the named access list here, right? So I could just choose the name that I've used before here, or just specify the number that I used before for the standard or extended. So any of them will work. So now I can copy this one and say, okay, that's the one I want to use here, and paste it to internet, and I want to do it. See, it's very easy to know if I'm going out here to be able to reach the destination. I need to say outbound. If the traffic is coming in this place, I'll say inbound. It's very easy as relating to the device you're configuring on. So if I'm configuring on this device, the traffic is going from source somewhere in this source, or maybe somewhere here. It's going from here to somewhere outside of this particular device. And if it's going out, I'll say outbound. I'll say out. If it's coming in, if the source is somewhere there and destination is somewhere here, and traffic is coming in, I'll say in. So either outbound or inbound. It's very, very, very straightforward and easy. In this case now, I'll say outbound because I'd imagine the 1.1 is this way and the 3. something is that way. So if I say out, that will be the end of the command. Then I can hit my enter. And if I do that ping, only that packet will be allowed. Every other thing will be dropped. So that's how to put access control on the device, so that even though we have several things going on here, we don't just have all the things we've configured here able to access everywhere on the network. So we're able to only allow what's needed from one point to another. At some point it gets messy, then we get to clean up again. Just that's how an environment works. Sometimes these access groups or access that we have given over time might not be used again anymore, and maybe the people that configured it have left the company and nobody knows what those access lists are for, so we just leave the access list there. So another way for us to do cleanup is to find out how long ago has this traffic actually been used. Then we can put monitoring tools in place to check, okay, who is actually using this link. Has anybody used it for the last 1 month, 2 months, 3 months? If nobody have used it for the last 3 months, then we can think of maybe taking it off or just disabling that traffic. We might not necessarily take the ACL out. We might just disable that traffic by taking the application on that interface out. And if anybody don't complain, then on the later date you can just take the ACL out that was created for it. So remember, when you create an ACL, you must apply it on an interface before it can work. Otherwise, it will never, ever, never work. So you can try this out on your lab as well, and then put an IP address on this side of the traffic, put an IP address on the other side of the traffic, and see if you do your your configurations, and see if it will actually allow you ping from one side to another, if you are allowing just ICMP traffic, and if you're using TCP as well, you could just see if it's going to allow telnet port 30 to communicate between one point to another. So yeah, so that's it about access list. Really, there's really nothing more to add to that. There's so much more to add to it. Maybe when you go to a higher class, we'll start talking about very complicated access lists, but those access lists are all based on what we've just done, the standard, extended, and named access list. Okay, so I'll call it today. If you have any questions, please ask. Otherwise, I would say thank you for joining this class. Any questions? I know I went a bit fast on this one. Some people, I hope nobody has slept off. Hello?